Okay, so in this video, we're still on the 2018 Further Maths Exam 1, and we're still looking at the data questions. So this is question 12. So this is one where we've got a log y transformation. So because that was used to linearize a set of nonlinear bivariate data. We do a least squares to transform data. We get our least squares line here. Okay. But what we want to do is find out what y equals. So we actually want to find out what that y part there is. And the easiest way to do this is actually to use solve. And I'll show you why. So here's y. Because as you can see here, look what I prepared earlier type moment. I've actually put this equation into the calculator, the CAS, and then solved it using solve. So I've basically done solve because I actually want to find that value. So I've put my 3.1 as per there. I've got my 2.3 and my x is 1.1. So that's that part there. Do my comma, I'll do my y, and then I just press enter and it gives me that value. So you're not having to do any other transposing of equations. You're just using solve. It's an easy way to do it. That means the answer is E. Okay. Question 13, statistical analysis of a set of bivariate data involving these variables. Okay, and we get, oops, sorry about that. And we get this. Okay, so we've got our equation. Okay, now we want an R. You might think initially look at this and go, oh, how am I going to work out an R from this? Well, there's a set of equations you can use to actually calculate your A and your B. So to calculate that and that. Okay. Now, I'm going to show both equations, but we only need one. So one of the equations is B equals R SY, so that's times there, divided by SX. The other one is A equals Y bar minus B X bar. Now we don't need to worry about this one because we've actually got B, but these are the two equations you need. So for the moment we can ignore this part here. So I'm just going to get rid of that now. But I want to show that because that's where you've got, if you have something that looks like this, those are the two equations that you're potentially going to have to use, depending on what they're asking for. In this case, as I said before, this is A, this is B, so my B is already been indicated there. Okay, so I'm going to put 1.31 equals R times, and SY in this case is 3.24. I'm going to divide that by, so it was SY, SX is 2.33. And when I transpose that, or I could use solve, my R is equal to 0.94. Okay, and that means the answer is D. Now, the least squared line is fitted to a set of bivariate data. So we're on question 14 now. Another least squares line is fitted with these two variables reversed. Which one of the following stats will not change? Now, residuals are going to change because that's, remember, where it's looking at your predicted and actual values are. So that's going to change. The predicted values will change. The slope will change because it's going to be things are going to have moved, and therefore the intercept and least squares line, they're all going to change, which leaves C. And that actually makes sense because you remember the correlation coefficient is a measure of the strength of that relationship, and that's not going to change because it's been those two variables have been reversed. Okay, everything else will change though. So that question 14 was C. All right, the table below shows the monthly profit in dollars of a new coffee shop for the first 9 months of 2018. So we want to use the 4 mean smoothing with centering for the smoothed profit for May is closest to. Okay, so what I like to do with questions like this is to have something like this. Putting something like this in your summary book is a really good idea It's going to hide that answer there. So what I would do here is all I'm going to do at the moment is going to put, because it's January, to say January, Feb, March, April, May, June, July, August, September, and that's all we need. If I need all 12, I just write all 12, because I don't actually need to put the values for everything here. In this case, what I like to do is I actually like to work backwards a little bit. So I'm after the centered one for May. So centered one for May is basically going to be this one here. Okay. All right. So I'm just going to change colors a couple of times here just so you can see what I'm doing. This one, so that means I need to get these two values. Okay. That means to get, and here I'm going to do a bit of highlighter. Actually, let me go back 2 secs. I'm going to actually change that to highlighter. So that means that there, and I'll show you why I want to do that in a moment. Okay. Now that means I can go back and go and think, well, I need 4 for this. So I need to get, oops, thought I was on yellow again. I need that one. No, sorry, I need this one, because I need 4. I need 2 on each side. So I'm going to need those 4 there. And for this one, I need these 4 here. Okay. So what that means is all I need to put into my thing here is stuff from March. So March is 2402, 2402, 2456, 4651, 3456, and 2823. I don't need to worry about any other numbers in this question. Now, I'm doing it on this sheet. You might be doing this directly into your calculator as well. So you might be, not having to stress too much about that. But this is how I'm sort of working out what I need to do. So now all I need to do is look at these yellow ones to work out that value. And then I need to look at these green ones, so just the green ones there, to work out that value. Then I get the average of that, and that gives me my answer. Okay? And so I've actually done that already. So I'm going to get rid of that for now. So if I look at the grey, look at the grey one. So it's 2402, 2456, 465134. So that's the grey is this, and that's going to give me, since there's 4 of them, it's going to give me 3241.25. And then here I'm going to have, so this there is going to be this lot from here, and that's going to be 3346.5. And then when I get the average of those two, my answer is going to be 3293.9, or if I can put 0.875, but we're after the nearest number, so 875, which corresponds to 3294. Okay, 3294. That gives us our answer as B. Okay. Now, again, you could do that in a calculator, and there's ways you can actually sort of automate that, but those are the numbers you need. You don't have to put every number in. You just need those numbers that you're going to need, in this case, to put March to July in, and you work it out like that. But if you want to do it manually, that's how you can do it manually as well. Okay, so question 16. The quarterly sales figures for a large suburban garden centre in millions of dollars for these 2 years are displayed below. Using these sales figures, the seasonal index for quarter 3 is closest to. Okay, so what we need to do here is we need to find the, so remember, we need to work out the seasonal indice for these two. Okay, remember what the seasonal indice how we calculate that is the value of the season, okay, divided by the seasonal average. Okay, so what we need to work out first is the seasonal average for 2016 for 2017. And the way we do that is we add them up and divide it by 4, and that'll give us a value of 2.29. Okay, and for 2017, that'll give us a value of 1.58. All right, so from there, what we need to work out is the seasonal. So for seasonal indice for 2016 is going to be, so remember it's a value of season, so in this case 3.34 divided by 2.29, and that will give us a value of 1.46. Seasonal indice for 2017 is going to be 2.05, because that's the value of the season, divided by the seasonal average, which was 1.58, and that will give us a value of 1.3. So these are our two seasonal average seasonal indices. So 1.46 and 1.3. So the seasonal index for quarter 3 is going to be 1.46. So you get an average of those two, plus 1.3, divide that by 2, and you're going to get an answer of, let's change color, 1.38. Therefore, the answer is C. Okay, that is data finished for this exam. Thank you.